Hello, my name is Frank Perini, and today I'll be talking about earned value analysis. So if you're studying for your PMP exam, you're probably in the process of learning this analysis, learning the formulas for calculating this. And what I wanted to cover today was I think a lot of people have difficulty understanding what earned value analysis really means. And what I've noticed is a lot of people studying for the PMP exam, they really focus on trying to memorize all the formulas. And I think that's really not necessary. Earned value analysis is a very straightforward analysis, actually. It's a little complicated when you first look at it because we're talking about schedule in terms of dollars, which doesn't really make sense at first glance. But once you understand it, it's actually a very simple way of representing information. And what I'd like to first start out with, I guess, is why is earned value analysis so important, and why is it such a good tool? Well, earned value analysis is basically a way to look at the overall health of a project. It's a way to look at the cost, schedule, and scope, or you could say work status of a project. If you define that as scope, everybody knows that the triangle, there's scope, cost, and schedule, and how those three things kind of work together. Earned value analysis is basically looking at all three of those at the same time. So I'd like to talk about today, what each of these lines mean and why you don't really have to memorize these formulas. It's obviously a good idea to familiarize yourself with them for the exam, but don't get so caught up in memorizing all the formulas like, CPI, cost performance indexes, EV over AC. I've seen a lot of people, they just write down all the formulas and they try to memorize them, but it's really common sense stuff. So let's jump into it and let's understand earned value analysis. So earned value analysis has three lines. And we're going to talk about what each line represents and how that's used. So we have a green line, which is AC, which stands for the actual cost on a project. We have the PV line, which means planned value. And we have the EV line, which means earned value. So let's talk about what each of these lines actually means. Let's start with actual cost, because this one's probably the easiest one to understand. Actual cost is literally just the actual cost of a project that you've spent to date. So over time, as you work on a project, you're going to spend money. You're going to buy equipment. You're going to pay employees or contractors. And as you do that, your actual cost of the project goes up. It's like a cash flow. So at the beginning of the project, of course, it should be zero. You've spent nothing. And maybe from the first day, that's when you start writing checks to buy equipment, to hire contractors, to set aside money for budgeting. You start to accrue cost. And that's what the actual cost line means. It's very straightforward. It's just the actual cost that's been incurred to your project at a given point in time. Okay, so that's very straightforward. This is cost, and this is cost in terms of dollars. You'll see that this chart, let me put the highlighter on here. This chart axis is cost in time. So that makes sense, right? Over time, our cost that we've actually spent is going to go up until we finish the project. So that's pretty intuitive what that means. Now let's talk about what the earned value line means on the bottom, the blue one. So this one is the one that's a little bit unique. It's a different way of looking at it. Earned value is not actually looking at cost directly per se. Earned value is really a measurement of work output. Okay, it's a measurement of work. But it's basically work that's been converted into cost. So what do I mean by that? Well, let's say you want to build a road that's 10 miles long, and you've estimated that to build that road with contractors, with materials, you've put together a cost plan and a cost estimate. you've estimated that that road is going to take, $1,000 per mile. So if it's, just as an example, so if it's $1,000 per mile and you have a 10-mile road in your project, of course, that's $10,000. And what the earned value means is for every 1 mile that your project completes, that your contractor, your material readiness, every 1 mile that is complete on your project has earned $1,000 worth of work. You originally planned for $1,000 per mile, and every time you complete a mile, your project has earned that $1,000 worth of work. So it's a way of converting work and hours and material. It's a way of converting work into dollars so that it can be compared with the actual cost. Okay, so that's a little bit tricky. So actual cost is pretty straightforward. The actual cost line is the cost, the actual money that's been spent on the project. And the earned value is actually the work output in terms of dollars of what it should have been. So if it should have been $1,000 per mile and you finished 3 miles of road, your project has earned $3,000 worth of work. Okay? So now let's talk about what's the plan value. Well, the plan value is basically the combination of those two kind of set as a baseline. So at the beginning of a project, you have estimated that this project will take a certain amount of time, a certain amount of money to complete. And of course, complete means 10 miles of road or 100% complete. So you've estimated that to get to your 100% completion, it's going to take this amount of time. It's going to take this amount of cost. And over time, this is what our planned value would be, because you might not build 1 mile of road starting from day one. You're going to accrue value over time, right? So that's the planned value. So the planned value is kind of like your baseline for the project. Your actual cost line is how much money you've actually spent to date at a given point in time. And your earned value is how much work output you've actually gotten. So again, just to maybe drive home the point here, let me add a note on here. Let's see. Let me go back to text. So you can think of the earned value line as dollars spent, or excuse me, the actual cost line is dollars spent. Okay. Right? This is the dollars that you've spent on the project, real dollars. And the earned value line down here, you can think of this as work output, in terms of value dollars. So it's really work output. It's not dollars that you've spent, but if you think that a mile of road is worth $1,000, then when you complete a mile of road, your project has earned $1,000 worth of work, right? So that's what the earned value means versus what the actual cost means. The actual cost is the actual cost. And of course, the plan value is the plan. That's the baseline. That's the plan. So at the beginning of your project, this is what you're communicating to the team. You're telling the team that it's going to take this amount of time to finish this project, and it's going to cost this amount of money, and this is the cash flow. We're going to spend this much money, or in terms of material, in terms of work, we're going to spend this much money over time. We're going to ramp up, and then at the end, we're going to kind of slow down and then close out the program. So that's why this graph is so powerful, because it lets you look at scope, cost, and timing all in one chart. So we've talked about what the 3 lines mean. Now let's talk about what does schedule variance and cost variance. So if you're studying for the PMP exam, you may have been asked to memorize a bunch of formulas and remember SV equals PV minus EV and cost variance, right? But let's think about what schedule variance really means. So schedule variance means that at a point in time, so this is the time now line right here, okay? At that point in time, the earned value line, again, that's not really representing dollars that you've spent. Again, that's representing work complete on the project, the earned value. So at a given point in time, if you have a plan and you should be here, you should have earned this amount of dollars in value, right? So if that equates to 7 miles of road, that would be $7,000 in our example. Your earned value line tells you where you're actually at as far as getting scope done, getting work done. And maybe you've only gotten 5 miles of road done. So your project has only earned $5,000. So that's why the schedule variance is represented by the difference between the PV line and the EV line. The reason it's the difference is the PV line represents how much work should have been done at this point in time in terms of dollars, like we just talked about. And the EV line represents how much work was actually done in terms of dollars. Okay, so that's your schedule variance. It doesn't necessarily mean you've spent more money than you should have or less money than you should have, because that's the AC line, which we'll talk about in a minute. The EV line just tells you how much work was complete from a scope perspective. And that's why this is called schedule variance, because it's a schedule metric. It's not a cost metric. Now let's look at the cost variance. So the cost variance is the difference between AC and EV, actual cost and earned value. So let's think about that. Actual cost is how much money you've actually spent on a project. It's real dollars, real money that has been spent. The earned value, again, is how much earned output you've gotten. So if you've built, let's use our example again, 5 miles of road, and you've earned $5,000 worth of work, right? You've earned $5,000 because you estimated that the value of 1 mile of road is $1,000. Well, if you've spent $10,000 to get that, that's not good. That means that you've gotten $5,000 worth of product and you've spent $10,000 to get it. That's effectively what that means. On the other hand, if we were to redraw this line, if it was something like this, this would indicate that we're behind schedule. We have a schedule variance here, right? We haven't gotten as much work done as we thought, but our cost variance isn't so bad. We're pretty close to on track. It means we're behind schedule, but we're not really necessarily over budget, or we're just a little bit over budget the way I've drawn it. It's pretty close. Does that make sense? So the earned value line represents how much work has been completed on a project. The green line represents how much cost has been accrued on a project. And it's possible to be late but not be over budget, right? So if this was our actual cost and this was our earned value in blue, that would mean that I'm on track schedule wise, right? I've built my 7 miles of road or whatever, but I've spent $10,000 to build $7,000 worth of road. So I'm on schedule. I've got 7 miles of road complete, but I spent more money than I thought I was going to. Okay? So that's the difference between schedule variance, SV, and cost variance. So you could memorize these formulas, but in my opinion, it's very simple. Your planned value compared with your earned value, that's a measure of scope that's been completed. So that's a schedule metric. And your actual cost spent on a project compared with your plan, that's a cost variance. Very straightforward. So let me undo that just to clean this up. So I think we understand what is the AC line. We understand the EV line. We understand what is the variance, right? So let's talk about another metric that's brought up, which is the cost performance index and the schedule performance index, right? So these are also relatively straightforward, and a lot of people memorize these formulas, but it's really just kind of common sense. So let's use our example again, where I'm building a road and I've well, let's just, to make it simple, let's forget about the difference in lines here. Let's look at, well, I guess we can keep it like this. So let's look at cost variance first. So the cost performance index. What is the cost performance index? It's EV, okay? So that would be here. Oops. EV, right? This point for today, divided by here. Okay, so what does that represent? Well, it's just a ratio. It's just a ratio that can be used to summarize the performance of this project to date, and it can be used to predict the future. So it's just a ratio. You're just saying that I planned to spend this much money right on my project. I've actually spent this much money, but I've only gotten this much work. So, and the reason it's divided by earned value and not the planned value, the reason that it's earned value divided by actual cost is, if you think about it, if you estimated $1,000 per mile, and you've actually spent $3,000, and you only got half a mile done, that's like $6,000 per mile, right? That's why you want to compare these two in a ratio. It's basically a way to normalize what's your actual cost ratio compared with what your plan was. Your original plan was $1,000 per mile, but if your cost is double and your output is half, that would be 4 times difference, because your cost is double times 2, but you've only gotten half the work done. So that would be 2 divided by 0.2, right? That would be a 4 times delta. That means your project is off by a factor of 4. You're spending 4 times as much money on your project as what your plan said you should be. So your CPI would be, in that case, it would be the inverse. It would be 0.25. It means it's kind of like an efficiency. You're only 25% efficient from a cost perspective, if you want to think of it that way. Okay. And schedule variance is very similar, right? We're comparing our earned value, how much work did we get done versus our plan. So, and this is kind of a good predictor for the future, right? So if I'm 25% late, let's say my earned value over PV is 0.75. Well, I don't know if in some projects maybe you have a plan to get back on track, right? But a lot of times you don't. So that kind of indicates these can be used as a performance indicator for the past. Here's the performance. We were off by 25% in schedule. But it's also a useful tool to calculate the future, which is why you use these to calculate the estimate at complete and the estimate to complete. That's one of the methods. Now, if you had a one-time cost, this is just a project management kind of best practice. If you had a one-time blip because there was like a special case, you may say, you know what, the CPI doesn't make sense. I'm not going to use that on my project because that was a one-time mistake. It should never happen again. There's no reason to think that all of the activity is going to be off by this efficiency factor, this cost performance factor that we call the cost performance index. But generally, if you're halfway through a project and you're off, let's say your cost is off by 25%, and you don't really see that changing, that's where the estimate at completion comes in. You would take your original planned cost, right, which was, let's say, in our case, what do we say, $10,000, and if your cost performance index is off, that $10,000 might now become $12,500. because you know you're off by a certain factor, a certain CPI number, and that means that's probably going to translate the whole project. If today you're off by 50%, probably all the tasks in the project, one way to simplify it is to say all the tasks will be off by about 50%. So we think the estimated complete is going to be off by 50%. This is your estimated complete. It's kind of your prediction of the future, right? You have a plan, you think you're going to spend this amount of money, but now you think, based on this cost performance index, we're going to take this original number. That's why the formula for estimated complete is the BAC divided by the CPI. You're taking the BAC, which would be here, right? And you're dividing it by that factor, that EAC. So if you're off by 50%, when you divide by 0.5, it would be like times 2. And that would create this number up here. So that's what the cost performance index is telling you. It's a prediction of the future based on the past. You have your plan line, your PV, and you have this cost performance index based on historical data, and you're just taking that and using this factor to calculate a new future. And you're doing the same with the schedule performance. You're saying, based on the past, we're either ahead of schedule or behind schedule by a certain amount, which creates that ratio. And I'm going to take my original finish date, right? And I'm going to push this line down so that it's going to take all the way out to here, right? To get to that earned value of 100%, or that earned value of the total cost of the project, right? So it's pretty intuitive when you think about it that way. The actual cost line is just actual cost. The earned value is the amount of work done in terms of expected cost, right? In terms of market value, if you will. The plan value is just the plan. It's here's how long it was going to take, and here's how much money we were going to spend, right? And then the index is you're just comparing your earned value versus your cost. And you're just comparing your earned value versus your plan. And that gives you a performance index. So your cost performance is just comparing the cost. Your schedule is just comparing the schedule. And then to calculate the estimated complete, to calculate the estimate to complete and the cost, at completion, you're just using these factors times your original plan. It's kind of like saying I'm going to look at the historical data and just use that to estimate the future. So that's earned value analysis in a nutshell. I mean, I hope that was kind of a clear explanation. It may take you a few times to, work through some problems, but don't overcomplicate it by thinking about the formula. Just think about how much work was done, how much work should have been done. That gives you your index. What should the cost have been? What was the cost? That gives you your performance index, right? If you built 1 mile of road, it should have cost $1,000. If it cost $2,000, well, your cost performance index is 0.5, right? And it's the same thing with the schedule. If you've built 1 mile of road and you should have built 3 miles of road, that means your schedule performance index is only 1/3, 0.33. Right? Very common sense. And you're just going to use those and take your plan value and divide by those, right? And that gives you a prediction for the future. That's earned value analysis in a nutshell. It's very simple, but it's very powerful. It lets us look at cost, schedule, and work all at the same time. So it's a really great tool, and that's why I really recommend you try to understand it as much as possible, not just memorize all the equations for the test, but really understand it, because this is a great tool to use on your projects in the future. So I hope you enjoyed this video. I hope it was helpful. Please like and subscribe my videos. I'll be doing a lot more work to bring you good material to help you guys prepare for the PMP, and also good material just to help provide you with best practices for professionals, and help you in your careers. So thanks again for watching, and I'll see you in the next video.